Hello everyone. In this session, we are going to see about Unit 2, Transverse Loading on Beams and Stresses in Beams, introductory part. In the paper CE8395, Strength of Materials for Mechanical Engineers. The gist of this presentation will be introductory part of supports, beams and loads. These are all the concepts which is available in the Unit 2, Transverse Loading on Beams and Stresses in Beams. So let's get into this session. Why are we going to discuss about this concept? As a mechanical engineer, we always work with machines under structural loads, or we will be going to design constructions with different types of supports and beams. This is a basic concept for an engineer to be aware of, to do all such things. By the end of this concept, we are expecting a student will be capable to identify all the supports, beams and loads. Particularly in this session, we are going to cover supports. So what is meant by a beam in engineering? What is meant by support? What is meant by load? These are all the basic things one should have to know for studying this paper. First one, what is meant by a beam in engineering? A beam is a structural element which is capable of withstanding transverse loads. Simply, a beam transverse, it's applied loads to the supports. So what is meant by a support? A support is an element which bears the weight of a beam and keeps it upright. Simply, we can say that it is a thing which keeps beam in equilibrium. So support is a major thing that it helps to maintain the shape of an object by observing the load. What is meant by a load? A load in this concept refers to the forces acting on structures. This is the reason this can also be called as structural loads. So what are all the forces that can be available in the topic of beams, supports and loads? So forces that act on a body can be divided into two primary types: applied and reactive. In common engineering usage, applied forces are forces that act directly on a structural like dead load, live load, etc. Reactive forces are forces generated by the action of one body on another, and hence typically occur at connections or supports. The existence of reactive forces follows from Newton's third law, as we know that every action that is an equal and opposite reaction. So now in this session I had concentrated mostly on supports. Further videos we will see about the beams and loads. So supports. Why the supports are mandatory? To bear or hold up, serve as a foundation or base for any structure. To sustain or withstand without giving way. It is an aid or assistance to any structure by preserve its load. Supports are used to connect structures to the ground or other bodies in order to restrict their movements under the applied loads. The loads tend to move the structures, but supports prevent the movements by exerting opposite forces or reactions to neutralize the effects of loads, thereby keeping the structures in equilibrium. So basic thing the supports are there for to maintain the structure in equilibrium position under extreme conditions, that is by means of several types of loads and pressure. So what are all the types of supports? So based on the concept, how they are supporting the beam, they are classified into four types: fixed support, simple support, roller support, and then hinged support. So let us discuss all these supports one by one. Fixed support. This support keeps the end of the beam fixed, as you can see that in this image. Um, yes, the beam end resists to take any kind of translation or bending moment. So translation or bending moment. So in the below figures we are going to see how the support will be. So fixed support. So this is the support given for this beam at one end. So it's a fixed one. So it resists the forces or bending moment whatever we are applying on this beam. Fixed supports can resist vertical and horizontal forces as well as moment, since they restrain both rotation and translation. They are also known as rigid support. So fixed support is otherwise known as rigid supports, as because of it restrain both rotation and translation. So translation means linear and rotation means angular. So this is also another example of this rigid support or fixed support of a beam which contains at both the ends. So this is a live example for this fixed support or rigid support. As you can see that this bridge is where is available. I think we are all know about this bridge. Next one, simple support. In this type of support, the beam is allowed to rest freely on a support. So this beam is support at both ends, as we can see this in this image, and thereby we can observe that the beam is free to move in any direction and also to rotate about the support. Hence it is termed as simple support. It does not resist or restrain the translation or rotary motion as in fixed support. So this is also an example for this simple support. It just supports the beam, but there will be either translation or rotary motion. And then roller support. A roller support gives capability of movement to the respected beam connected to it, maybe along normal to the gates, or it can also rotate about the support, as we can see in below figures. So this is a roller support. As we can see that above this roller, whatever the beam is provided, it can provide translation movement. And this is also another example of this roller support, a rolling chair or an office chair, so that it provides translatory motion from one place to another by means of rotary motions. So roller support. Roller support are free to rotate and translate along the surface upon which the roller resists. The surface can be horizontal, vertical, or sloped at any angle. The resulting reaction force is always a single force that is perpendicular to and away from the surface. So consider this is a beam, this is a roller support, and hence it also provides motion or resistive force towards y direction and as well as in x direction if the support is provided like this. So restrains the structure from moving in one or two perpendicular directions. So by giving this roller support, either one or two perpendicular direction, it restrains the structure. This is also another example of this roller support. This is an example for doing exercise, and This example is also well known that it is used in sports. So these are all the possible methods of designing the type of support, which is roller support. So by these models we can able to design the roller support. And then hinged support. A hinged support restricts the movement of the beam in any directions, but it will allow the beam to rotate about the support, just like a door, which is a best example of hinged support. So this door is an example of this hinged support, so that it can rotate the door by angular means. A hinge support can resist both vertical and horizontal forces, but not a moment, which means, so the door is an example, it resists horizontal and vertical forces, but the movement cannot be resisted, as because the door can be opened from the closed position and can be closed from the open position. So they will allow the structural member to rotate but not to translate in any direction. Pin or hinge support is used when we need to prevent the structure from moving or restrain its translational degrees of freedom. So this part is the main part. So a hinge is a type of bearing that connects two solid objects, typically allowing only a limited angle of rotation between them. Two objects connected by an ideal hinge rotate relative to each other about a fixed axis of rotation. So this is a hinged support. So this red arrow mark will be the reaction at x direction and as well as in y direction. So this is a padlock for hinged support example, and these are all the forces at x direction, forces at y direction, forces at z direction in the hinged support. So this is an example from the top of the view, so that you can able to see that it resists horizontal forces and vertical forces, but not the movement of this object. Another example for hinged supports. And these are all the beams with all the supports. This is a beam with fixed support and with a roller support, hinged support, and with a resistor roller support, which means it resists the movement in y direction, not in x direction. It can be movable but not in y direction, but this resists both x horizontal forces and y vertical forces, but not the movement. This is a roller support and this is a fixed support. So I think from this session you can get an idea about the transverse loading on beams introductory, along with the brief description about supports and its types. So we will see in the next video. Thank you.